Hello, Professor. This is my term project demonstration video for this course of medical AI. So here, as you can see, I have already placed the code here. So the first task is here to import libraries and dataset. And here, as you can see, I have recently run the code. And after importing the libraries, I connect my drive, Google Drive, for the dataset import or for the dataset access. And here, as you can see, the directory is placed, and here we are listing the folders in the directory, and we have the image generator here. All of the details are going to be presented in the report file. Here, as you can see, is the train generator. We have the validation generator then, and then we have some necessary libraries installed. So going down the file, we have some labels here, one hot encoded labels. So we got 4 classes here, or 4 different labels. And here are the list of the labels. As you can see, COVID-19 normal, pneumonia and bacterial pneumonia. And yeah, we have here the list of them. Yeah, I can just run it here. As you can see, it will show. And I could run some other image here, for example, number 8. So yep, here we got the image. And then we have some visualization. And here are the results of the visualization. So we got normal, bacterial pneumonia, and etc. And so here is another grid of subplots. And if we go down here, we have to import model with pre-trained weights. So I'm using ResNet 50 as a base model. And I'm going to use pre-trained weights because of the scarcity of the data set. So I'll just freeze most of the model, and let's say I just will train the last 10 layers of the model because I'm using ImageNet weights, so they're pretty big. So I'll just have to fine tune. Here, as you can see, it is already run here. So I have recently run it. It is going to take some time if I run it again. So and here I just freeze the layers. As I said, the last 10 layers are learnable, and the remaining ones are not trainable. And here we train the model, the last 10 layers, sorry. And here's the summary of the model. And then we have compile the model. And we also use some early stopping method to, save some time and just not waste in our time in not learning anything. So, and here we found 428 images for 4 classes and 104 images for classes for training and validation. And here's the history of fitting the model. As you can see, from epoch 1 out of 50, epoch 2, epoch 3, 4, and etc. And here we have the inclusion of JSON module to save the model. And then here we load the model, and then we evaluate the trained deep learning model. Again, we compile here. Here's our test directory. And let's just go down. So we install OpenCV, and then we go down and import some metrics as confusion matrix, classification report, etc. And we have here the following. So the accuracy, test accuracy is 82%. And here is the demonstration of the results. As you could see, here's guess COVID-19 and the true label is COVID-19. So let's look for something that was not predicted correctly. Well, I think here all of the predictions are correct. And here we have the classification report. So precision, recall, and F1 score, etc. And here's the confusion matrix. So 4-class and 4-class. So yeah, this is it for the presentation demonstration. So here's something else I think I forgot to mention, which is I used RMS prop for optimizer because I found it to be the most effective in for the specific task rather than ADAM, adaptive momentum. So I just can't exactly locate the cell, the code cell. It should be somewhere. Here it is, RMS prop. So this is the optimizer that I used for this project. And thank you for your attention. So I'm going to stop the recording.